everybody. Today we're going to be starting our last conic, which is the hyperbola. The hyperbola's equations, they will translate with the minus h minus k, just like we did with the ellipse. You will notice here, though, instead of a plus in between here, now we have a minus. What's going to change here is that the a squared and the b squared will not be shifting. What will be shifting is the x squared and the y squared, depending on what kind of parabola it is. If the parabola is hugging around the x-axis or kind of heading out horizontally, then the x squared will be the lead term. If it is going up and down like this, then we will have a y squared hyperbola. To solve for the c, again, remember that is the distance from the center to the foci. For the ellipse, it was a minus. Here it is a plus. So if there's a minus in the main equation, there'll be a plus here, and then vice versa for the ellipse. Let's just kind of teach this through examples. Let's kind of go to the first problem here. So I'm looking at example 1, and I can clearly see that it is a hyperbola because of this minus sign here. So even if we don't tell you what it is, you would be able to tell because of that minus. We do not have the minus h minus k, so I can tell that the center of the hyperbola is sitting on the origin. I could also see that my a squared and my b squared are the same value, which is absolutely fine for this guy here. So I know that my a value is 2. I also know that my b value is 2. And what we're going to do, we're going to use these to create what I'm going to call vertices and co-vertices, even though they're not exactly on, well, the vertices are, the co-vertices are not on the graph. So I'm going to count out 2. I can see this is an x squared, so this guy is going to be going this way. So 1, 2, 1, 2. So those will be my vertices. My co-vertices are also 2, so I'm going to go up 2 and down 2. The way we graph the hyperbola is what I'm going to call, we're using a box method. So you're going to use the vertices and the co-vertices to create this box. And that's going to help us to get some asymptotes going to help us with the rest of this graph here. So once I have that, what I want to do is figure out the line, I'm going to do this in green here, that's passing through these points, and again the other one going this way. And that's going to help us to get the shape of our hyperbola. Okay, we're calling these asymptotes here. We're not going to touch. The hyperbola is basically going to hug around them. So this is going to be the equation y is equal to plus minus x. I have a y-intercept of 0 going up 1 over 1, up 1 over 1. That takes care of the plus. The other one here going down 1 over 1, down 1 over 1. That's where the minus is coming from. We have found our vertices. So they're at plus minus 2, 0. Our co-vertices are at 0, plus minus 2. So once I have that in here, we can create our hyperbola by going from the vertex and just kind of hugging along these asymptotes here. What I'm missing from the graph at this point is our foci. Now foci for the hyperbola are going to be out inside of the hyperbola itself. Now what I said is going to be a squared plus b squared is equal to c squared. So it's going to be 4 plus 4 is equal to c squared. 8 is equal to c squared. So I know c is going to be 2 square roots of 2, and that is about 2.8. So if I count 1, 2 plus a little bit more, 1, 2 plus a little bit more, and that's where our foci would be sitting. Again, we need exact answers here. So this is going to be plus or minus 2 square roots of 2, 0, because we're moving left and right. We're bouncing off the 0 of the center. The major axis is also called a transverse sometime. We're going to think of it as a major axis because it's passing through the main vertices. And again, I'm just looking for the equation of it here. So that's going to be y equals 0. The minor axis will be running through the co-vertices, and that's the equation x is equal to 0. All right, let's try example 2. Oops, sorry about that. Example 2, there we go. The hyperbola, just like the ellipse, needs to be set equal to 1. So the first thing I'm going to do is divide everything through by 36. So that's going to get me y squared over 9 minus x squared over 4 is equal to 1. I can see this is a y squared lead hyperbola, so it is going to be going up and down. I don't have the minus h minus k, so my center is sitting on 0, 0. The main vertices are coming from this number right here, and the square root of 9 is 3. So our a value is 3. Because it's y squared, we're going to be heading up and down. So 1, 2, 3, 1, 2, 3. So our vertices are at 0 plus minus 3. Our co-vertices come from the b value here. Take the square root, we get 2, 1, 2, 1, 2. So our co-vertices are going to be plus minus 2, 0. And again, what that creates is the box to help us find our asymptote. So I'm going to create the box. I'd like to see these in dashed lines because it's not really part of the graph. Okay, so from there we got to find our asymptotes. So that's the next step that we're looking at, is to find our asymptotes. So if I look here, to get to this point right here, I have to go 1, 2, 3 over 2. So the slope of that line is 3/2. To go in the other direction, I'd go down 3 over 2. So the equation we are looking at is y is equal to plus or minus 3/2 x. So again, this is not really part of the graph. The asymptotes are guides, so they should be dotted. So we're going to have one going that way. Do the best you can, keeping everything nice and straight. Okay, so those asymptotes provide the guide for us. We can actually get the hyperbola in there right now. So you start on the vertice and you head up, because this is definitely a y square, so that should not be there. And then again from the other vertice here, heading down. What we need at this point is our foci. So again, since there's a minus here, is going to be a squared plus b squared is equal to c squared. So we're going to have, let's see, 9 plus 4 is equal to c squared. C squared equals 13. So our c value is going to be plus minus the square root of 13, which is about 3.6. We need the decimal for the graphing. We need exact answers here, so we need to use the radicals over here. But 1, 2, 3 plus a little bit more, down 3 and a little bit more. So the graph is complete. Because the foci are moving up and down along this major axis sitting here, it's going to be bouncing off the y coordinate of 0. So this is going to be 0 plus minus square root of 13. The major axis is now this vertical line, and again, sometimes it's called the transverse. X equals 0. The minor axis running through the co-vertices this way is going to be the line y equals 0, and that minor axis sometimes you'll hear as the conjugate? I think conjugate. Alright, so let's go to the other page. So just a little vocab here. A hyperbola is a conic section that consists of all points whose difference, and that's where that minus is coming from in the a squared minus b squared, from two fixed points, and those are our foci, is constant. So for the ellipse, the distance is added together. For the foci, it is subtracted. The foci of a hyperbola lie on a line called the major axis. The hyperbola can be drawn using two oblique lines called asymptotes. And those are those lines that help us guide how the hyperbola is stretching. Hyperbola always intersects its major axis at the vertices. The center of the hyperbola has the HK, just like all our other shapes did. Example 3 and 4, we're going to be moving off the origin. So let's take a look at those. Again, they're shifting with that minus h minus k, just like we've done all other problems. So the first thing, I'm looking at this, I see there's a minus, I know it's a hyperbola. I can see it's a y squared hyperbola, so I know that I'm going to be stretching this way. Be careful with your center when the y is first. We've got to pull from the x coordinate and then the y. So our center is going to be the point 3, -2. So 1, 2, 3, 1, 2, there is our center point. I can see that my a value is 3, and because it's a y squared hyperbola, I'm going to count up 3. 1, 2, 3, and down 3. So those are our vertices. I can actually see these points here, so they're easy to guess. So 3, 1, and the other one is 3, -5. Our b value, so we take the square root of that, is 2. That will get us our co-vertices moving right and then left. Again, I can see those points as well, so they're pretty easy just to grab off the graph itself, and that's 5, -2. Once we have our vertices and co-vertices, that helps us to form the box, which is going to help us guide our asymptotes. This is going to have the same slope as the one prior. We're going up 3/2 or down 3/2. So the asymptotes are going to look like this. And again, they're there to help us guide how the hyperbola is getting onto the page. I do want to write these in point slope form. And if you remember from Algebra 1, that's y minus y1 is equal to the slope times x minus x1, and the point that we're going to use is the center point. So what I'm going to have here is y plus 2 coming from this over here, because of the minus, it changes signs. We said the slope is plus or minus 3/2, and then it's going to be x minus 3 from that coordinate there. So that's how we're going to be writing the equations for our asymptotes. Once I have all that in, I can write the graph or draw the graph. So let's go. We're heading up, so it's going to look like that. Do the best you can to hug around those asymptotes. Alright, so at this point, the graph is pretty much drawn. The only thing I'm missing from the graph is our foci. So again, it's going to be a squared plus b squared is equal to c squared. We just did this problem. We did get c to be square root of 13. And again, that is about 3.6 for graphing purposes to get the foci where it needs to be on our graph. Because I need exact answers over here, and we're going up and down, we're going to add that plus minus square root of 13 to this y coordinate. So it's going to be 3 minus 2 plus minus the square root of 13, and that will give us the location, the exact location of where that foci is. The major axis will be running through the vertices, so in this case it is the line x is equal to 3, and the minor is going to be running through the co-vertices here, so that's going to be y is equal to -2. Okay, we've got one more example to work on. Example 4, we are given in general form, so first thing we need to do is get it over to standard form. So what we're going to do is, now looking at the general form here, because there's a minus in front of either the x squared or the y squared, that's how I know it's a hyperbola. Even if I'm not told, that minus is going to let me know. The x squared is positive, so that means this is going to be an x squared hyperbola. So I'm going to gather up the x's together first. Leave a little bit of room to complete the square. It's going to be, let's take that parenthesis off for just a second. It's going to be minus 3y squared minus 6y. And I'm going to bring that 4 over to the negative side. Remember to switch the signs. I'm going to factor out a -3 here. That'll help us to get the negative into the hyperbola formula. So 3, so it's going to leave me with y squared plus 2y. And now I'm going to go ahead and complete this square. So half of 8 is 4, 4 squared is 16. If I add 16 to the left, since there's just a 1 out here, I'm going to add 16 to the right. Half of 2 is 1, 1 squared is 1. But I'm not just adding 1, it's 1 times this negative 3 up here, don't forget the negative, and that would be minus 3. Factoring both, we wind up with x plus 4 squared minus 3 times y plus 1 squared, and that's going to equal 9. Now remember, the hyperbola formula needs to be set equal to 1, so we're going to go ahead and divide everything through by 9, and we wind up with x plus 4 squared over 9 minus y plus 1 squared over 3, and that's going to equal 1. So this is the formula that we are going to be working with. I can pull the center point. This is an x squared. Our hyperbola is going to be going this way. It is going to be negative 4, negative 1. So let's see, 1, 2, 3, 4, down 1. So there is our center point. Our a value is going to be 3, because the square root of 9 is 3. So 1, 2, 3. Oop. Boo-boo there. This is an x squared. I went the wrong way. 1, 2, 3. And then 1, 2, 3. Our b value is going to be root 3, so I need to take the square root of this here. And that turns out to be, square root of 3 is about 1.7. So we're just going to have to guesstimate. It's 1 plus a little bit more than half, 1 plus a little bit more than half. That helps us to create the box. That's going to help us with our asymptotes. So if I think about what our asymptotes are here, again, I need to get those lines in. That's going to help us to guide what our hyperbola looks like. Again, since they're asymptotes, I prefer they be dotted. So I need to get the equation. We're going to use our center point here. So I know it's going to be, let's see, y plus 1 is equal to, now in this case we're going up square root of 3 and over 3, so it's going to be plus minus square root of 3 over 3, and then x plus 4. So there's the equation of our asymptotes. Our vertices I can see. I could pull those off the graph pretty easy. So minus 7, minus 1, minus 1, and minus 1, minus 1. Good. Our co-vertices are here and here. Again, I need exact answers. Since we're going up and down, we're going to bounce off the y value of that center. So it's going to be minus 4, minus 1, plus and minus root 3. So that gets us the exact location of our co-vertices. I do know my hyperbola is going to be going this way, hugging around. It's a little bit off the graph, and that's okay. At this point, we still need to get our foci. So it's going to be a squared, which is 9, plus b squared, which is 3, is going to equal c squared. C squared is equal to 12. So c is going to be plus minus 2 square roots of 3. And that turns out to be about 3.5. So 1, 2, 3 and a half. 1, 2, 3 and a half. So our foci are now on the graph. Since the foci are stretching left and right, they're going to be bouncing off the x-axis of our center. So it's going to be minus 4 plus minus 2 square roots of 3, negative 1 for the y-coordinate. Last thing we just need to fill out here is our major axis is running through the foci and the center and the vertices. That's going to be y is equal to negative 1. And our major axis running up and down this way, x is equal to negative 4. And with that, we conclude the first lesson on hyperbolas.